It's great to be here. Thanks to the GDevCon team for everything. We'll be doing some polls a little bit later, so you can use that QR code to get there. This presentation, so Steve Watts, who's not here, but did kind of help instigate the first GDevCon in Cambridge. He and I have shared this trait of going down rabbit holes, reading old computer science textbooks and papers and things like that. And so this kind of came out of that, where we were reading some papers about modularity and so on. So that's where this thing came from. And I actually, submitted this several months ago and then kind of forgot what I submitted. And I knew the title, but I didn't know what I was going to talk about. And so then a couple of weeks ago, I said, well, I should really read what I submitted and try to make sure that it matches. And so what I submitted was pretty good. So I still don't know what I'm going to present today, but it seemed like a good topic. I also, there's AI came up twice yesterday. It came up in Eric's and in Nancy's presentation. They both gave a history of AI, and I kind of felt like, well, one, I was there during the history of AI, and so I felt like there was some people that were left out of that. So like I think Eric said, Alan Turing, kind of the inventor of AI, and I really view it as more people like Marvin Minsky and Newell and Simon and John McCarthy at Stanford. Those to me are more of the people who invented AI that were actually doing things in the 50s and the 60s. First boss I ever had is a guy named Woody Bledsoe, who was a professor of mathematics at the University of Texas, and then he created the computer science department. He was president of the American Association of Artificial Intelligence back in the 80s. His speech as president of the AAAI was, I had a dream, and his dream was talking about all the things that AI could do, and if you go read it today, it's actually just as relevant about what AI could be used for, what good it could do, but also with some of those same warnings that we have today too. The other thing when I was thinking about AI, and I just added this slide yesterday, is that when I was at NI Tech 2000, which was an internal R&D conference, I did the first presentation on artificial intelligence at NI. And I thought I'd actually revisit some of those slides real quick to talk about what are the things that we thought back then. Let me get it to present. Keep going. Dr. Signal is still a good idea. I still talk to Karsten about this, but let's. What tools do you think of when you hear AI at NI? Natural language processing, computer vision expert systems, machine learning. So this is what we were thinking 24 years ago. Code generation and wizards configuration. Some of this stuff actually made it into DAC-MX. There's some things like signal routing and DAC designer that were. There was going to be an expert system inside of DAC-MX until I helped kill off that idea. But anyway, so all this was stuff that NI talked about a long time ago, and is finally getting around to doing something about. Nearly there. Okay, so first up, our giants are female. You're getting two of them today. The first one is a woman named Annie Ford. She just finished riding her mountain bike from Baja California to Whistler, up the western coast. She's a marine scientist. She used to work in the oil and gas industry as a marine observer. And basically, she's from Australia, from South Australia, and she has, besides being a marine scientist, she's also this amazing mountain biker and surfer and has this world record holder. But she's been raising money to stop seismic blasting in the Southern Ocean south of Australia, which is decimating the sea life in that area. So that's one of the our giants are female that I wanted to highlight. It has an Instagram channel right there. The other one, which we're using this one from NI Connect. If you were at NI Connect, you saw that. If you were at my presentation, you saw this. Cole Brower I guess a couple of months ago, just finished being the first U.S. woman to sail around the world nonstop alone. She was in a race with, what it says, 16 competitors, 15 of them were men. She's 5'2". She'd been part of another team, and they basically said, "You're too small to do ocean sailing, ocean racing." So she proved them wrong. And she just finished second place there and finished in a record for her class, even of men or women. So I wanted to highlight her. That's her Instagram right there. Okay, who am I? Let's see, what do I say? So LabVIEW, I've been working in the LabVIEW world since the dawn of time. LabVIEW champion, CLA, and professional instructor. I worked in the LabVIEW R&D team. I know how a lot of LabVIEW works inside even today, even though it's been 10 years since 15 years since I touched any of the LabVIEW source code. I'm on the Austin Opera Board of Trustees, so I care a lot about that organization. The things I'm passionate about are things like team culture. I've worked so NI had a great culture. I worked at a company called Athena Health. It's just healthcare, IT. Amazing culture until it completely disintegrated and collapsed. So I care a lot about team culture and organizational structure that supports that team culture, and then the people management that goes along with that team culture. And then good software engineering processes are just something I've always cared about, even at NI, and created some of those engineering processes when we didn't really know what we were doing, but we knew we needed to do it better. So, first poll comes up. So pollev.com/bhpowell, there's somewhere. Let me know if you can't see it. Oh, it says I have 74 responses, but it's not showing up on the slide. That's a shame. We'll figure out something when it gets a little bit later. Agenda, why is modularity good? We're going to talk about modular organizations, and we're going to talk about modular behavior. So that's the plan. So this is going to be a question to you. Why is modularity good? Let's see if I actually see anything. If not, I'll switch to the web page, and we'll do it that way.
You want an essay? Oh, one word.
Reuse seems to be winning.
If you put decoupled and decoupling.
Yeah, coupling and cohesion. I don't know if I see cohesion up here, but coupling, definitely see that. Okay. Okay.
You caught me.
Well, y'all can keep going on that. I'm going to switch back to the presentation. Fine. Okay. So one of the papers that I was reading was called Design Rules. There's actually a book called Design Rules. There's Design Rules 1, and now there's a Design Rules 2. And then there were papers written by the author about design rules, so design rules past and future. And I really like this quote. He was doing basically an economics, financial, business view of systems, and like looking at disruption, things like how, DEC with microcomputers or mini computers disrupted IBM, and then microcomputers came along and disrupted the mini computers and so on, things like that. So the virtue of a modular system is that its components can be mixed and matched to achieve the highest value configuration in a particular setting. So the modularity, the value is that you can mix and match and put the things together the way that make the most sense to you. to you, the person who's putting those modules together. And so that last sentence, the essence of modularity lies in the options it gives designers to postpone and then revise key decisions. And so I'm going to harp on that for a little while. But that to me was like, oh, that's telling me what the value is of, I see these things, I like the way this is put together, or I don't like the way this is put together. And a lot of it has to do this, well, when do I have to make the decision on what I'm going to do in my architecture, what I'm going to do in my organization? If I can postpone that decision as much as possible, that's a good idea. And Dr. Touchard, who was the founder of NI, had this thing. I'm not sure if I remember exactly the words he used, but it's essentially like this. You always find a decision invariant path forward. Like, go forward, but do it in such a way where it doesn't matter what the decision is. So if the decision changes, just keep going forward, and hopefully, you don't have to change too much. The more you can not box yourself in a corner, the better you are. And so that's one of the things that I think modularity gives us. Modular designs create options, but modular designs can also evolve. Like, those are the two things that I want you to come away with. So what do those mean? Development can proceed opportunistically and incrementally with each module on its own semi-independent trajectory, right? So we think about open sourcing the icon editor. Thanks, Jim and Kring, wherever you are. That is basically letting the icon editor have a different semi-independent trajectory from whatever LabVIEW, NI, somebody else wants to do, because it's now its own separate module, its own separate source code, its own GitHub repository, so it's independent. And that's an example of that. It's creating an option by spinning it out and making its own module. Modular designs can evolve. So design change is driven by search processes that we use on deciding, is this a good approach or is it not a good approach? And that's based on me as a developer of the module or a user of the module, what is good. Sometimes that's me imagining how it's going to be good. Sometimes it's putting it into practice and seeing what works and what doesn't. So that survival of the fittest is what allows us to continue to evolve on these modules. But it takes place within, like the icon editor is an example of, well, it's still in this LabVIEW ecosystem and still has to plug into LabVIEW. So it's not completely independent, but there's a place for it to evolve. All right, so let's talk about modular organizations. So this is where I think I wrote, maybe 15 or 20 slides about what I thought NI should do. And then I said, well, the right people aren't going to be here from NI. So I still boiled it down to one slide about what I thought NI should do. But that's part of what this is. But I also think it applies to all of our organizations. It certainly applied to the organizations I've worked with about how to make them more modular. So what traits would a modular organization have? And so I may need to go activate that. Let's go see. How do I go to the next one? Next one here. Activate. Flexible keeps showing up. Interfaces, that's an interesting, yeah. Adaptability, that's a good word. Communications. And somebody said interfaces earlier. Who said interfaces? Somebody want to acknowledge that? Okay, what do you mean by that?
In order for it to be modular, you're going to have some way of
Yep. So a modular organization, you still need to define those boundaries. Who do I talk to when I want to do something, when I want you to do something, or I want you to help me do something, right? And so defining that communications authority is also an interesting piece of that puzzle. But yeah, I mean, a lot of times you build a modular organization, but you don't define those interfaces, and so then you end up with just more confusion. It's like an isolated module because there's no way to ask, like I feel sometimes that way with NI. It's like, who do I go talk to at NI to go open source the robotics module? So it turns out it's Sergio. Because I talked to Eli, I talked to Eric, I talked to somebody else, and so they all kind of lead here. And so yesterday I said, here's why you should open source the LabVIEW robotics module. But that's like, I think having you in that role is a big step in defining an interface. But still, there needs to be a public interface of if you want to do these things, here are the people you can go talk to. So let's see, what else? So independence, we talked about semi-independent trajectories. I think that's a really important, the module gets to choose what's right for that module to a large extent independent of what may be good for another module. Let's see, respect. That's an interesting thought. Respect, some of that's respect for the boundaries of those modules, of those parts of the organization. I need to respect that this is your job. That, your job is to go and figure some of this stuff out, and I'm not going to take that job away from you because you have that job. And so I want you to have that authority to be able to do that and not steal that from you. Okay, we'll leave that running, and then we'll go back to the presentation. Which still doesn't have any responses. Okay, so next question is, do you work in a modular organization? And so let me go activate that one. So it's a nice bell curve we have here. So I'm kind of curious on the two extremes. We'll start with the absolutely not, do not work in a modular organization. What to you is, one, does it work? What are some of the pain points that you might have? What are maybe some of the good things about it? So anybody, Alan, you want to?
It's me and my intern. So, I'm a modular one, which is by definition not modular.
Yeah.
It works just fine because we're very, very, very small.
Okay, so this is where we ask you to leave the room, and then we get Megan's take on.
Including telling you she doesn't want to answer, but that's okay.
We'll talk later.
It works.
Yep.
I can go ask Kim if I need help on something.
Yep. Okay. Anybody else in a absolutely not modular organization that wants to offer anything up? Okay. Somebody at the other extreme, definitely modular, flexible organization. Who wants to talk about what's good, why it works, how does it work? Talk about that. 14% of you said you're in such an organization. Nobody wants to admit. Okay, right there.
So this actually wasn't what I voted for, but working in a startup, especially a small group of people, like everybody knows what all the roles are for everyone else, and that's where I could see that being that category.
Yeah. So small startup. And I would say at some point that startup, it may still be a startup, but it's no longer a small modular startup. Because I worked in like a 100-person startup that wasn't modular.
Right, and
But
that's
I
where you
could
need
certainly see like then you're in one of these 10-person startups where everybody has to do every job, or be able to do every job.
Right.
And then you start to figure out, okay, you're good at this and you're good at that, but I can help you if you need that. Aaron, I think you had a comment.
So I'm also the one-person organization, but answered the opposite, because for me, the modularity is mindset. Am I willing to adapt to changing requirements? Am I willing to, or am I going to just say, no, this is how we're doing things, and just bull straight ahead as this is the only correct approach, versus being willing to say, to adapt?
Yep, that's a good point. You can be, a lot of it is your behavior and how you wear your different hats as your sole proprietor. I try to do that same thing too. Okay.
The interface to the module that is Alan C. Smith or Aaron Gelfand is the interaction to our business, our contract with our employers. And that is external to us and what we do. Any module, in software, a module can do whatever the hell it wants inside the module, right? It has effectively no rules except the ones the designer imposes upon it. So I think that's, Aaron and I are probably in violent agreement, but it's a semantic difference as to whether, Aaron, I think you are equating modularity and flexibility, and I'm actually making the opposite argument that when you have a single entity, you're by definition a module of one. And I think that's true in our software too, right? Just another parallel example, right? You get to a small enough module and it's the atomic unit. So how can that be any more modular than that? Or how can you make that modular?
Yep. I do think that y'all are in violent agreement. But I also think that there are organizations that are absolutely not rigid that don't function well as well as yours does, right?
Different axis of discussion.
Right, exactly. Yes, exactly.
Can I add one more thing? So I didn't feel like we got a strong answer from somebody that felt like their organization was really modular. I'm loving the company that I'm working at. Each person and each group has very defined roles, and there's like defined handoffs of information, whatever your value package is between groups, and the processes are really well defined. And one of the great things one of the great benefits is that that can scale really easily. So if a particular project or even just the company as a whole needs to scale, then you just add more modules and everybody understands how that works. Or you add people to the team that fall into a particular role, that team can scale and everybody understands what the inputs and outputs are. Yeah, and defining those interfaces. That reminds me, and we'll get to you here, don't forget, we'll get you a microphone. When I was a manager on the LabVIEW R&D team, I don't remember what year this was, but we had kind of switched from like when I first started in the LabVIEW R&D team, we had two small rooms, windowless rooms. There was the front panel room and the block diagram room. I was in the block diagram room. And so our interface was a door in between. That's how the interface between the front panel and block diagram worked. But eventually we grew to a point where we created different teams that were responsible for different things, such as a user interface group. And I managed what we call the LabVIEW measurements group, which LabVIEW internally within NI had grown to this thing, where all the other parts of the company have to interface with LabVIEW, right? That was just something Dr. G said. Everything has to work well in LabVIEW. But the interface to the LabVIEW R&D team wasn't well defined. That how do you ask the LabVIEW R&D team to do something for you? And in reality, the answer was whatever you're asking for. The answer is no. That LabVIEW has its own priorities, and your priorities don't matter. If we can do something for you, great, but if we're not going to go out of our way. Well, the LabVIEW measurements team was
part of our mantra was to switch that around so that the answer was yes. So every team that came to the LabVIEW team, we would figure out a way to accommodate their needs. And so a lot of that was like what went on with DocMX. All the things that enabled DocMX from LabVIEW were things put together by my team. Some of the things like the waveform graphs and the digital waveform graphs and the digital waveform data types, the timestamp, all these things were created to say yes to what the doc team need or the vision team need or motion team or whatever other team. And the other piece of that puzzle by defining that interface is, there were big parts of NI like DAC, data acquisition, modular instruments, that could usually force LabVIEW to do something for them. But then there's all the other small groups like vision and motion that like represent a few percent of LabVIEW's customer base was motion. But if you flip it around and look at what percentage of motion's customer base was LabVIEW, it was like 98%. And so anything that the LabVIEW team could do for motion had a huge impact on the motion profit and loss. And so that was why it was important to default to yes instead of default to no when other teams came and interacted with us. And so by defining that interface of just being our team was the interface to ask LabVIEW to do something for you, that really opened the door for a lot of improvements that we were proud of. Jörg.
Actually, and surprisingly, I have a serious question. When you think about modular organization, do you have people in mind and HR and how they are separated? Because it sounds like most of the answers revolved around being a team of one, which means something. But that's only one aspect, I guess. The other aspect is like the responsibility or the tasks or like the whatever it is. So how do you see that?
I mean, I do see it. I mean, it's all companies are made of people, right? So absolutely, I see it as people. Most of my experience is working in, I worked in $2 billion companies with thousands of employees, and I worked in a 100-person startup, and then I worked for one-person thing. So most of my experience has come from the large organization stuff, and so that's what I really have in mind is how do you create modules in that organization. And so what I'm about to talk about is kind of how it doesn't work if you think of it as a billion-dollar company as a monolith, right? Just like it's a problem with, well, a giant healthcare IT project that I worked on that was a giant monolith. It had a bunch of problems, but how can you refactor that into something that's better?
So is it test? Is it fair to say that it boils down to separating people into groups? Is that the essence of it?
That is one approach. It depends. As you know, I like to say. It is a common approach. Okay, so segue to the next part. So one of the reasons I left NI was this question. So NI I left NI 10 years ago. So NI is different today in many ways. But one of the things that I was always frustrated with was, somebody comes up with a good idea and some VP somewhere says, but can it scale? Like it's got to scale to the entire NI customer base. It's got to scale to the entire employee base. Whatever it is, it's got to scale. And so I believe that's one of the decision paralysis problems that NI had that led to some of the mistakes that NI has made is that it had to scale, right? And this is the monolith, right? This is whatever you do, I want a LabVIEW, the field architect program was me and Nancy and a guy named Charlie Knapp in California. There's 3 of us. And we showed how what we were doing, which was basically helping customers get better at LabVIEW, meant that they became better NI customers that bought 7 times more NI products than other customers. And we had that question, but how does it scale? It's like, well, we need to hire, 100 Brian's and Nancy's and Charlie's. And even then, that's probably not enough to scale worldwide, right? So therefore, we're not going to do it at all. Like, we're just going to kill off the field architect program. And that's when I decide, well, it's a good idea, and it's so frustrating you're not going to do the good idea because of this question right here, right? So that right there is more or less why I left NI, out of frustration with that. I do not believe that this has to be the way you operate. So to me, the opposite of that is modularity. It goes back to that Carlos Baldwin thing. Basically I can mix and match the good ideas and put them together. And so, for example, like the field architect program, maybe you just do some of that somewhere. Maybe you just do that in the large accounts. Let's just go hire 5 or 10 field architects and go and do it that way. It doesn't have to scale to every customer in our database. It doesn't have to scale to all large customers. It could just be a good idea that's one of the many things that a company does. Right? So this doesn't just apply to NI, it applies to a lot of companies that I think have this decision mindset of, I can't have like these small groups that are doing these things that are independent of, everything has to scale. Everything has to work universally everywhere within the company. I do not believe that is true. I think that kind of goes against what Carlos Baldwin has. Okay. I can't remember if I hid the next slide. I may have hid the next slide. Nope, I left it in. So this is one of the things I kept telling several people at NI Connect, NI people, is like, I still see some of that old NI mentality in places at NI, and that needs to change. And so I'm hopeful that this will change, that Emerson will have more impact on how NI operates. But I do think that there can be some modular good ideas. So examples are like outsource all the good ideas that NI is not going to work on. Open source them. Icon it, LabVIEW Robotics Module. LabVIEW Robotics Module last updated in LabVIEW 2019, 32-bit. You're not going to work on it? Open source it. We're getting there. Support those things with time, expertise, and money. Academic presence for NI, right? Used to be an academic sales force. The academic sales force used to go to universities and help ensure that LabVIEW is successful there. It was a lot like the field architect program, which is why I actually reported to that manager for a while. You no longer have an academic sales force, but don't just walk away and leave and just let it wither and die. Leave it for dead. Instead, take some of that money. You don't necessarily have to fund it to the level you used to. But pay for partners to go to your university and support LabVIEW. They'd be willing to do it. They're maybe not willing to do it every week for free. So there's that. So some hints. Lab Community Training Initiative, academia, open source projects. Hey, look, LabVIEW Robotics.
Brian, tell us what's your favorite part. What's your favorite module?
64-bit LabVIEW is my favorite NI product I worked on. That was so much fun. There were 3 of us. Does Dowd still work at NI? No, so we're all gone. Okay. Modular behavior. Okay, we're running out of time. So how does this affect what I do every day? So here's your question. Let me switch over to these slides. Earth 2. Activate. How do you create modular code? And your choices are top down or bottom up. And so do you create the VI and then you start creating sub-VIs, or do you have a reuse library that has everything that you need in it and start to put everything up? I think Derek has a question if somebody wants to run the sandwich approach. Yeah, a little of both. Well, that's why I made this a one or the other. I just was forcing people into a camp. And it's more or less 50-50. I'll see if I can, well, I'm seeing the numbers come in. It's 45% A, 50, now it's up to 59% B, bottom up. 41 to 59, 40 to 60. Okay. In the interest of time, I'm going to keep going. Okay. So remember this. Modular designs create options. Modular designs can evolve. And so let's talk about the search processes you use to evaluate these things. So how do you evaluate a modular design? So that's our next poll question. So let me switch. That's our last poll question too. And so it's activated. Let me stop the slideshow so that it will. What happened to that? It depends. Oh yeah, that must have been my joke. There's your answer. So you all voted correctly.
Love you, Frank.
Yeah. And thanks, Jörg, for setting up the earlier part. Okay. Home stretch. Let's see. Okay, so here's some things that I wrote down in the it depends category. So maximum reuse, especially if you're building a reuse library, that's, I'm going to do things that are going to be most reusable. What I need right now, absolutely a viable way of evaluating whether it's a good module or not. I also believe, like one of the things I tell people about hardware abstraction layers or measurement abstraction layers is like the first one doesn't count because you only have a case study of one. And the second one, you start to have an idea about what makes a good abstraction layer, but it's really not until you have a third and you've moved from the point to the line to the plane. Now you're getting a better idea about what that abstraction layer is going to be. Is it similar to what I've done in the past, which I think is another reuse thing? Performance, simplicity, flexibility. And then this ability to change my mind and do something different. That's actually something I thought of a week or so ago. We were having a discussion about DQMH, I think with Steve Watts. And one of the things that he said is like, Steve Watts does not use DQMH. He has his own LabVIEW component-oriented design approach. And it's not that he's not a fan of DQMH, it's just he doesn't use it. But he says, the faint praise for DQMH is that you almost never hear of anybody completely screwing up their application by choosing DQMH. And it's like, well, it's so...
That was a British compliment.
Yeah, that was a British compliment. Very nice, very British. But this idea of, I can change my mind halfway through the application, and I don't have to rewrite everything. That's one of the things I like about LabVIEW object-oriented programming, is I can pick and choose where I use it. I can use it just here, and the rest of my application doesn't have to know anything about OO. Same with DQMH, is that I can choose to have a DQMH module in my application, but I'm not committing to this framework everywhere for everything I'm going to do. And so I like that idea that decision invariant path forward is like, well, I'm going to choose DQMH, but I may change my mind later. And hopefully I haven't boxed myself into a corner. The flip side of that is sometimes a good module is something that's imposed by my framework. And so, if I'm building an actor, and I'm going to be working in an actor framework mode, having something that looks like an actor that just plugs in right here is a great way to evaluate that. Another one, solid principles. Who doesn't know what solid means? It's okay, you can raise your hand. Okay, so, Uncle Bob Martin. I don't really like solid because I think it's really hard to remember what solid stands for. Liskov substitution principle. Now, okay, yeah, we remember what it says, but we don't know what it means. Right, which Liskov substitution says that I can substitute one and not change the behavior.
You're the only woman on the solid.
but that's, there's some good ideas in Solid, and so that kind of object-oriented thing is another good evaluation criteria. Besides, it depends. What are some other evaluation criteria you decide on what makes a good module? Raise your hand. Fabiola.
You didn't raise my hand.
But I knew you had something to say.
I always have something to say. What makes a good module?
What makes a good evaluation criteria for what is a good modular interface or design? Or
Can I test it easily on its own without having to create a huge harness?
That is a big one right there. Yeah, everybody's nodding their head over here. So yes. Yeah. Can I test it without having to mock a bunch of modules or set up a bunch of hardware or something like that? I just want to test this timer over here, but no, I've got to have all this infrastructure. And that's something that, you just sort of thinking of test from the very beginning, which is one of the other things I like about DQMH, is that testing is right in your face. What else? What are some other evaluations? Right, Kevin?
Ease of use through debugging.
Yeah. Can I debug this thing? Can I understand what it's doing when it's misbehaving, or when I think it's misbehaving, or what it did when it died?
That's right. Or developer versus executable RT. There's a whole lot of issues that may perk up. So
yeah, once it's deployed, now what's it doing?
Exactly.
All right, over here.
When you come back to it 6 months to a year, or you're onboarding new hires, how long does it take to remember what the hell you did?
Yeah. I often wonder that about code that I've written. It's like, what was I thinking? Though one of the things I say about the code that I wrote when I was in NI, there's some of the code that I wrote in LabVIEW that is still in use today and still will be in use for another 10 years. I don't know if it should, but it was simple. It did very specific, clear things, and was very focused. And so that kind of idea of focus of what this code does, and it's kind of a coupling cohesion thing. But you can come back to it years later, and it still does the same thing, and you can still see how that works. Is there another one? Okay, Alan.
How good is its boundary? I.e., how much can I ignore what it's doing internally and just deal with it as an API?
Yep. Chris?
I think you can easily inspect it for cohesion, right? Or you could see if it's a hairy terminal block or something, or just think about, what is it doing?
Yeah, I think it's part readability, part debuggability, so on. Serge?
What is the average proficiency of the audience that will be maintaining it? Like how good is that audience that will be maintaining it over the time? Like, what is the average, and how will it be maintained toward that?
Yep, and I think that's really important from a reuse library perspective, is who's going to reuse this code? And is it somebody who has to be an expert in the framework or an expert in a whole bunch of LabVIEW technology to be able to use it? Or is it just a sub-VI I can drop on my block diagram and it works, right? And that's, again, kind of comes back to, like, one of the things I like about OO is that I can have this VI that uses OO, but I can just drop it on the block diagram and have no classes as part of its inputs or outputs. And I have hidden that, I've created a boundary that hides a lot of that complexity. Hunter.
Last question. I find that sometimes I make things modular that maybe I shouldn't have, and we've been talking about reasons that you want to make things modular. What are some of the reasons that you don't want to make things modular, or reasons that you're like, I put in a bunch of overhead and I could have hard-coded that and it would have been fine?
That's a great question. I have my thoughts, but some of you may have thoughts too. But sometimes it's like overly modular, and it's like almost a premature optimization thing. I think I'm going to need to use these 10 things independently, but it turns out I always use them as one thing. And so I may keep them as a module, but just have one icon that I use everywhere. So sometimes will see that. And it's really only a problem if I start stumbling over those interface boundaries among 10 things, when it's like, well, if I just had this piece of information over here, this would all work better. So that's an example of that. Any other things that anybody want to add? Okay, final thoughts. So, from that earlier quote, the essence of modularity lies in the options that it gives designers to postpone and then revise key decisions. So think about that as you're coming up with your architectures, as you are coming up with your modules. Is how can I choose that decision invariant path forward? How can I just keep moving? Move towards the finish line, don't box myself in, use the modularity as my tool for avoiding those decisions that force me into specific things. Okay, so with that, I am done. Thank you all very much.